You have a serious voltage drop on your system under load was a message that I received on one of the videos which I made recently, which was how I went about setting up my Victron Orion XS DC-DC charger 50 amp to give me those 50 amps when my engine is at idle. And to add to that, I've now added a second Victron DC-DC charger, which is also a 50 amp Orion XS. So I now have two chargers. So I now can pull 100 amps out of my alternator or battery, whatever way you want to look at it. And I know exactly what everyone's going to be saying. Oh my God, you're going to be blowing up your alternator. Well, that may be the case, or maybe it's not. So in this video, I'm going to show you exactly the way the system is working and exactly how many amps I am actually pulling out of the alternator or battery. So I'm going to show you that as well. So of course, I'm going to show you exactly how much voltage drop I've got on those cables, which go from my battery to the back of the van onto my DC-DC chargers. And I know for a fact it's like 0.2, 0.3 of a volt possibly. So I've got minimum amount of voltage drop, which is exactly what I was expecting on those 25mm cables, which I've used. So if you're new to all this, like I was 2 years ago, you don't even know what a voltage drop is, I'm going to show you exactly what it is. So hopefully you can understand it a little bit better. I'm going to show you how you can work out what size cables you should be using from everything from your DC-DC chargers to the lighting circuits in your van. So in this video, I'm going to show you exactly what's going on in my van. So how those two DC-DC chargers working and why I'm not blowing up my alternator. And this alternator in this van is 180 amps. And I'll show you exactly where you can find out how big your alternator is. Here's something else really interesting. Did you know these vans have something called regenerative braking? Look at my voltage there. It jumped from 12.6 volts up to 14.8 and now it's dropped back down to 12.6. So yes, these alternators do produce a high voltage. And of course, I'll show you that in a bit more detail in the video. Now, just going back to that comment which I had, which was you have at least 2 or 3 volts drop on those cables. Obviously, that was totally incorrect. And that's why I wanted to put this video out. The person who put it up obviously did have good intentions. But the problem is completely incorrect information, and other people have seen it and probably picked up on it. There was other people making comments as well. And the whole problem is there's so many experts out there and only a few of them are real experts, and I am no expert, but I'm just sharing with you the information which I have found out about this vehicle. Whether yours is different, it might well be, but I'm just showing you what my van is doing. And hopefully it give you a better understanding of what these smart alternators are about, Euro 6 vehicles and all the rest of it. Now this guy had a Ducato 24 and he said it worked absolutely fine. But my van, it does not do that at all. Now this is a Volkswagen Crafter medium wheelbase 21 plate. And it has got some really smart electrics on it. I'm really impressed with the way a lot of it works. And I just want to show you exactly what I found out. Because like I said, if you've got DC-DC chargers, you probably find that they aren't doing what you expect them to do. Because of these smart alternators, the smart electrics, the smart ECUs, everything inside this vehicle keeps the voltage really low. It's really impressive. But anyway, stick around if you want to find out more about it. But everything I found out is really interesting. And if you like all that geeky stuff, I'm sure you'll like this video. And of course, I'll be making a video very shortly about those two DC-DC chargers. I've also recently done an oil change, all the filter changes. So I'll show you how you can easily go about doing that. And of course, there's that problem I had with the DPF. I had an engine light on. I've taken all the sensors out. I cleaned them all up. And that was a whole amazing stuff. There's like 20 sensors on the exhaust. What is that all about? But anyway, if you want to see more of that, then obviously stick around and do subscribe. Click on the old thumbs up. And like I said, share it with everyone else on the van community. Okay, so let's take a look at my battery right now. So this is my engine battery and I've got a multimeter plugged in right here. So I just got a cable on the neutral and another test point on the positive. And you can see right now my battery is at 12.8 volts. It's freezing cold right now. I mean, it's like 3 degrees or something. And if we look at my DC-DC charger, so this is my second charger, my number 2. We got 12.8 volts, so it's just rounded that figure up to 12.8. If we take a look at my other DC-DC charger, this one here, the first one, we're going to have exactly the same voltage. Anyway, it's just getting information, and there we are. We've got 12.9 right now, and that's because the voltage just here has just jumped a little bit. It's just rounded that figure up again, and you can see it's it's sort of fluctuating around the 12.8 volts region. So that's exactly what I'm expecting. Now what voltage drop is, we have these cables connected here. So these are my cables which are running back to DC-DC chargers. I have two cables connected on here. I have two fuses protecting those cables, and they run back to the chargers. Now what voltage drop is that the voltage here is 12.8 volts. When it comes out the other end and connects onto the DC-DC charger, if you've undersized your wires, then the voltage will be lower, and that's what voltage drop is. So I could have 12.8 volts here, and when I start the engine and the DC-DC charger is running, depending on how much you've undersized your wires, depends on how much lower your voltage would be at your DC-DC charger. Now the danger is, if you undersize your cables, whatever you've got those cables connected onto, that appliance will keep trying to pull through whatever amperage it requires. So my 50 amp charger is going to keep trying to pull 50 amps through one of these cables. So if I've undersized it, besides getting a voltage drop, that cable's going to start getting hot because the charger is going to keep pulling that 50 amps. So think of it like friction. The electricity is trying to flow through the cable, but because it's undersized, it can't do it easily, and it starts rubbing on the sides, creating friction, making the cables hot. If the cables are really undersized, then the cables are going to get really hot to the point that they will start melting and catch fire. So that's the danger of undersizing cables, and I hope that all makes sense. I know the voltage drop on here is absolutely minimal. It's spot on what I was expecting it to be. But what I'm going to do is I'm going to show you this. I can check my multimeter and actually check it on the DC-DC chargers. Obviously we would also be able to see the voltage here. We're able to see the voltage change there, and we know exactly what's coming in. Now on my last video I showed this voltage here and 50 amps being pulled out. What this person said was that I had a massive voltage drop because I was only getting 12.9 volts. He was saying my alternator should be running at 14.5 volts. Well, that may be the case on an older or different vehicle, but these new Euro 6 vehicles don't do that. And again, I can prove that to you and show you exactly what's happening with these vehicles, because over there on my dashboard I've got a little device there which should tell me exactly how much voltage is on my van. And we can also double check it down here, and we see exactly how much is being created by the alternator. So that's going to be really interesting. So let's start the van up and see what we get. So push in the clutch, turn the key, and there we go. Engine on, not in gear, we're good. And there we go. Here's my little gizmo over here. Tell me exactly what's going on with my van. So that's my RPM, that's the van temperature right now, that's the fuel rate which it's using right now, and it's actually at 0.5. It's slightly higher at the moment. It usually goes down to 2.5 litres per hour on idle. And importantly, on the top here we have the voltage, and that is how much voltage is being read by the ECU right now. Okay, so it's only 12 volts, and what people are saying is that when you start your engine, that alternator should kick in and start producing more volts. It doesn't do that on these vehicles, and I'll demonstrate that to you in just a minute. But let's take a look over here. Again, you can see down there, hopefully. Let's try and zoom in. There you go, 12.9 volts. That's exactly the same as this over here, 12 volts. It's just 0.1 of a volt different. And if we look at my DC-DC charger, we've also got 12 volts here. And the voltage on my leisure battery is 13.3 volts. Let's just take a look at my battery. So where's my frog start? There it is. There's my battery. Okay, so my battery is at 75% right now, and we got 0 amps going in and going out, so you can see there's nothing going on right now. Now what I can do now, you might be thinking, well, why isn't your DC-DC charger kicking in now? Well, that's because it's not turned on, and I deliberately put some switches in up here so I can switch them on individually. This is a third switch, a spare one, so this one doesn't do anything, But this is my first DC-DC charger, and this is the second one. I've also got this little unit here, which is pretty handy. I've just fitted that. I got an alarm there, and I got my 2 floodlights either side and my rear floodlight, and I'm going to aim to put more lights on there. But that's pretty handy. Look, I can just press that in emergency. There you go. Anyway, I'm digressing. Right, let's get back to this. So you can see we've still got 12.1 volts here. We've still got over here our 12.1 volts down there. Nothing's changed. Right, let's put on my DC-DC charger. So let's switch that one there on. There, it's switched on. And let's take a look at my voltage and see if that changes. So you can see the voltage has dropped now. Now you'd expect the alternator to kick in and start delivering more voltage, but it doesn't do that. Now I believe this is because the engine battery is fully charged. And I initially thought that all the current was being taken out of the engine battery and allowing the engine battery to discharge to around about 70%, where the alternator would then kick in and recharge it up to its full power again. Maybe it does do that when only a small amount of power is required, because that's what I read in the research that was telling me how these Euro 6 vehicles and smart alternators work, which does make perfect sense because that's what the battery is supposed to do. But I bought this little gizmo and it turns out that that's not the case at all. So you can now see that I've got 12.2 volts and I've just turned on my DC-DC charger, and we see the charger is now activating, and then we can look at this little device here and you can see the amperage is going up. We've now got 46 amps, which the alternator is producing. We've got 50 amps, 51 amps. And you can see on the Victron app, I've got 50 amps being pulled out, and the voltage is now reading 11.7 volts. And the reading on my battery is now 11.97 volts. So even at a really low voltage, my alternator is still chucking out 50 amps. And yet it still hasn't increased the voltage. So if you leave your Victron charger at its default settings, it's not going to be turning on, or it's going to turn on and then go back off again as the voltage drops slightly. Isn't that crazy amazing? Now, if I turn the fan on, that always increases the volts, and you can see the volts increasing now, but I'm not sure whether that's because the fan also pulls 50 amps, or that the ECU knows that you've turned the fan on, and so it increases the volts. So the fan at full power always increases the volts and draws 50 amps at full power. So you can now see that I've got 13 volts. The alternator is producing 100 amps. And the engine is still just at idle. I'll show you what happens when I put the second DC-DC charger on later in the video. Now if we take a look at my charger here, you can see we've got 37 amps going into the battery now. Let's just come out of here, have a look at my DC-DC charger, see what that's doing. And there we can see we got 11.7 volts. Okay, and then we got 43 amps being pulled out, and we got 13 volts going here into the battery. So that's why we haven't quite got that full 50 amps, because the voltage here is a little bit lower. And like I said, what people are saying is you'd expect this voltage to be higher. They want to see the alternator kick in, but it just doesn't do that. That's not the way these vans work. So that's why if you've got your DC-DC charger, you expect it to be charging, it's not going to be charging. And I'll put some special settings into this to get it to work like this, and it's, as you can see, it's working fine now. Look, we've got a current there of 50 amps. It's pulling out of the battery and it's converting that into 41 amps. And you can see when you look at the watts there, they're pretty much the same. We've got 586 and we got 574 on the top there. So yeah, I'm happy with that. That's doing exactly what it should be doing. And just to demonstrate a little bit how this thing works, if I turn the fan on, okay, let's turn this fan on. You put it to full power, there we go, full power, and you watch that voltage change now. There, look at that. The voltage has gone up to 13 volts. I turn the fan back down again, and the voltage drops back down again, because the ECU inside the van recognizes that it doesn't need that power. So it just switches off the alternator. Let's just turn the fan back on again. There we are. See the voltage rising back up, 13 volts. And let's take a look over here now. We got 13 volts on the gauge there, and then we got 12.2 volts here going in. So the voltage drop which I have is 0.2 of a volt. See, this is 12.8 volts, and on the battery right here we got 13.04 volts. So that's pretty much 13 volts. So you can see here we got 12.8, and now it's pulling out 50 amps because the voltage has gone up, and now we've increased our amperage here because the alternator is now kicking out more volts. And I hope that's all making sense to you. I can now go to the back of the van and use the multimeter and check exactly what voltage I've got in case there's a small discrepancy with this, but you can see at the moment I've got 0.2 of a volt difference. And you can see my engine is still at idle all this time. I haven't speeded the engine up at all. And we've got 13 volts here, and the fan is running at full power. Let's just turn the fan off. And let's just increase the idle speed. I need to finish explaining this voltage drop and how much I got on these cables. So I'm going to show you some more really interesting quirks about the fuel, the RPM, and my little gizmo after I finish showing you exactly how much voltage drop I've got on these cables. Just before I do that, I just want to show you this cable sizing chart. You can find these on the internet. Just do a search for DC voltage drop chart. Now you use this chart to work out the size of the cable that you should be using to get the minimum amount of voltage drop. Now this might look a bit complicated, but it is really straightforward. So let's start here. Circuit type. What sort of circuit is it? Is it a critical circuit or a non-critical circuit? Now critical circuits would be things like my DC-DC charger, all connections around my inverter and battery. And I'd want the minimum amount of voltage drop on those cables. Whereas a non-critical circuit might be a lighting circuit, a fan circuit, a pump circuit, and there we could accept a bit more of a voltage drop. So this cable is going to be for my DC-DC charger. I want a minimum amount of voltage drop. So I'm going to be looking at these numbers here. Now, the next part is just basically how long is your cable going to be? Obviously, you got it in feet or you got it in meters. And obviously a non-critical circuit, you've got exactly the same again. So I look down at my charts here because I'm using meters, and it was about 5 meters. So here we got 4.6 meters or 6.1. Let's maybe make it 6.1. Make sure I cover myself that the cable is long enough. So I need to use this line here. Now the next part is how many amps am I going to be using? So I'm going to be using 50 amps because it's a 50 amp charger. So I'm going to be pulling 50 amps down that cable. You could size it up and go to 60 amps if you wanted to, but let's just look at 50 amps. So this is pretty straightforward. So I said 6 meters. So let's follow this line along until I get to that 50 amps. Now, if it was only 4 meters long, I could go up to this gauge here and you see it's 6 gauge wire. Or I could go to a higher amperage, and there you can see we've got 4 gauge wire. So for my 6 meters, I've got 4 gauge wire at 50 amps. Now I thought I'd just point out, if we look at this 10% voltage drop and we look at that where this is at 6 meters, you could run it at 19 meters. I mean, that's like, well, a lot farther. But of course, you're then going to get that 10% drop, and the cables would probably start getting warm or hot as it starts losing that energy in the cable. So I'm going to stick to that 3% critical circuit at 6 meters, which gives me 4 gauge cable. And then I look at this table over here, standard and metric wire comparison table. And we look down here at 4 gauge wire. And there you go, look, 25 square millimeters, exactly the cable which I have used for my DC-DC chargers. And I've only got 0.2 or 0.3 of a voltage drop using this size cable. Now I could go the next size up, go to 2 gauge wire, but of course that's going to be much thicker cable. It's going to cost a lot more. And then I'm going to gain what? Maybe 0.1 of a volt difference. It's just not worth it. And also 35mm square cable will not fit in the DC-DC charger's connections. So I'm hoping that all makes sense. If we take a quick look at the non-critical circuit, maybe say a lighting circuit, with a 10% drop I could run it 9.1 meters. I'm going to draw a maximum of 5 amps. That gives me 15 gauge wire. Take a look at the table and you can see we got 1.5mm square cable. So here I am in the back of the van and you can see all my electrics just here. Now that's all behind a plastic screen here, just protecting it all just in case something falls on it. Now this is my 50 amp charger just here. You can see that running away, and we can see we've got the absorption light on there, and we got this charger down here. I've only just finished doing this one, so you can see the cover isn't fully on this one yet. And look, I've got my probes onto the connection, so I've got, that's the live in straight from the battery, and we've got the ground connection there. And what voltage have we got here? 11.6 volts. And if we look at my charger, we got 11.7 volts. So you know that 11.7 reading there was what, 0.2 difference in the front of the van, and there we got the same reading here. We can easily just take this off and go and check in front of the van now. So we got 11.6 volts here going into the charger. So let's go straight to the front of the van and see what we got there. Okay, let's go. I'm going to do this in one hit so you know I'm not making any of this up. Let's go around to the front of the van here, down here, put my charger, a multimeter down here, stick that one in that little hole there, fits nicely, stick that one into there, and what's our voltage reading? 11.9 volts. So there's a small voltage drop of 0.3 of a volt, which I'm really happy with. So I just realized something. I can show you exactly how much voltage drop is coming off these cables here. So you can see the cable there, and you can see it drops down and down underneath there. And I can show you exactly how much voltage drop there is because I can measure the voltage here, like that. So that's in and ground, just there. And then we got 11.6 volts. Hopefully you can read that. Now if I put my probes on this one, which isn't actually operating right now, so it's just going to give me a voltage reading because there's no power being drawn by this charger. So you got 11.9 there now. Isn't that interesting? And there you go, still got 50 amps being pulled out, charging up a battery. So I think that clearly shows that I don't have a crazy voltage drop, and I hope it gives you a better understanding of exactly what a voltage drop is. Now let's go back to quirks of this van and what happens when I increase the RPM, and let's take a look at that fuel consumption. Okay, I want to keep that in focus up there, 12 volts. There we go, increase my speed. And you can see it doesn't make a blind bit of difference to the voltage here. And we're now at 2000 RPM. Because I'm stationary, the maximum RPM we can go to is 2,500. It won't let you go above that. So that's another interesting quirk about this van. So look, if I put my foot right to the floor, there we are, look, I'll show you, look, my pedal right to the floor there. And yet, still at 2,500. How much voltage? 11.9 volts. Okay, so it just goes to show it doesn't make a blind bit of difference to the van, right? Okay, so now I wanted to show you what happens when I put my second charger on. So I'm just going to leave the RPM just a little bit higher because that means it's going to run the alternator a little bit quicker, cooling it down, because that's the main thing. If I pull too much power out of the alternator, there's a possibility it could burn out, and that's the kind of the danger side of it. But this is a 180 amp alternator, so it shouldn't be a problem. Let's just go up here, switch on my second switch, and see what difference it makes to the voltages down here, the voltage over there. So 3, 2, 1, switch it on. Wait a second because it takes a little while for it to kick in. Does it make a difference? So my voltage, my amperage hasn't gone up yet, and I know exactly why that is. It's because this voltage isn't high enough to kick it in, because I've got the second charger set differently to the first charger. So that's why that's not coming on, but I can fool it by turning on the fan. So let's do that. Let's turn the fan on. There, fan on. Voltage going up, 13 volts. And then we should see this amperage increase shortly. And you can now see the amperage going into my leisure battery is now 85.2 amps. So I'm going to jump in here quickly. I hope as usual you'll find this video useful. If you are, obviously give it the old thumbs up, click on subscribe, ring on the bell and share it with everybody else on the van community, because I do hope it's going to be useful to people to see exactly what's going on, well, inside these crafters at least. So something else I wanted to show you. So this is my fuel rate, litres per hour. This is quite interesting. This little figure here. I still got 12.1 volts being created by the alternator, or maybe that's the voltage in the battery. That's all the ECUs are reading right now. Okay, if we go down here again, you can see we've got exactly the same voltage down here. Now let's just turn on my first DC-DC charger. That's that one on now. And this is what's interesting here. So we've got this fuel rate. You see how the fuel rates just went up there. It jumped up and it jumps up a little bit more, showing that the engine is actually running a little harder now, and it's actually using a little bit more fuel. The voltage hasn't changed at all. Come back over here, voltage is now lower over here because it's pulling that amperage or voltage, we won't call it, pulling out from here. So that's why we got lower voltage there. If I put my second charger on, this is what can be interesting now. So we got this here, this fuel rate just here. We got the voltage exactly the same. Okay, let's put the second charger on just here, and it might do something, it might not. So see if that fuel rate changes. No, that's not changing. Let's go back to that charger. Now it may not switch on because I've got it set differently to the other one. So it'll only start charging if the voltage is higher. And you can see it's still off because the voltage is set on this one differently to my other DC-DC charger. But again, we can see we've got 11.9 volts here, and over there we got 11.7 reading on the multimeter. Let's just speed up the RPM. There we go, RPM increasing. We can see the fuel rate increasing just there, as you would expect, and the voltage is staying exactly the same. So I need to draw a bit more current out to get my voltage up a little bit. So let's go back to the fan, switch the fan onto full power, and there, look what the difference that makes. And you can actually hear my engine note dropping, and you can see the fuel rate increasing. See that? Let's just turn the fan off again. See the fuel rate changing there? Fan back on again. That's interesting, isn't it? And then see the voltage has gone up now. Now that's going to have kicked in my second charger, and there it is there. Look, my second charger is just kicking in now. So again, we've got now 50 amps being drawn out, and we've got 43 going into my battery. So let's just check what we've got on the battery, and there we go. Look at that. What voltage is that? We've got 86 amps going into the battery. No trouble at all. And we got the voltage down there of 12.8 volts, and we go back to the charger again, 12.7, 12.6 volts, so that might be rounded up, and again 12.7, 12.8 down there. So we're all good. But like I said, I don't like to run the second one, unless the voltage is a little higher and I'm just cruising along at a faster speed. So I'm going to turn the second one off. There we go, that one's now off, but I'm quite happy to leave the other one running. Right, now I'm going to go and check. Now I want to quickly show you that regenerative braking on the Volkswagen Crafter 21 plate. Now if you see what Google says, it says on a 21 plate Volkswagen Crafter, likely a diesel model with hybrid functionality such as Blue Motion technology. Regenerative braking is a fuel-saving smart charging system designed to recover kinetic energy when the van slows, rather than solely relying on the alternator during acceleration. So what does that all mean? Like I've explained, it's all about energy efficiency and turning the alternator off and solely relying on the engine battery to supply power to run the pumps and anything else needed to run the engine. That increases efficiency by switching the alternator off and not allowing it to be a constant drain on the engine. But then when we slow down, we take our foot off the accelerator, you'll see the voltage massively increase as the ECU switches on the alternator and draws more current out of it, making it more of a strain on the engine, slowing you down, I would say, marginally. So I'm just going along the road and I'm just about to go down a little bit of a slope, and I'll take my foot off the accelerator and you'll see that voltage increase. If I increase the RPM, makes no difference to the voltage. Look, we're still at 12.4 volts. But what makes a difference is when I take my foot off the accelerator, watch what that voltage does. Look, 14.9 volts. Now I'm just sort of coasting down the hill here, so I'm slowing down and that voltage is staying constant. And I've got a bit of a decline now. And again, you can see it's just staying at 14.9. I dip the clutch and let the voltage drop straight back down again. Change to another gear, change to third gear. There you go, RPM up again. Again, you can see 12.6 volts. It doesn't change at all. Okay, but as soon as I slow down again, so I'm just going to come down here. We're going down to the edge of the road. Take my foot off the accelerator, and there we go, 14.9 volts again. Dip in the clutch. Come to a standstill and we're back down to 12.6 volts. Now I thought I'd just add, yesterday when I was driving along, I was having a look at this and it went up to 15.1 volts. So that's the highest voltage which I've seen it read. But like I said earlier, super clever electrics. So I also wanted to show you this little gizmo here which I've just bought, and I'm just testing out to see how this works. I wanted to see how many amps I was pulling off my alternator at any one time. Basically to make sure that I don't overload the alternator. Now this came with a whole bunch of kits and a Hall sensor, and I just connected onto the battery there so I can get reading. So I'm just seeing what's coming out now. So I've just set the voltage parameters in, and you can see at the moment the charger here is turned off, and you can see it says that it's drawing 13 amps. So that's what the alternator is producing now, and it's bringing it around and going into that buzz bar which is in the front of the van there. I'm not sure what's coming into the battery, but that's what's coming off the alternator. Okay, so that's pretty good, and you can see this is still turned off, 13 amps just to run the van. I could try to turn the radio off. Let's just put the fan on, because that likes to use a lot of power. Let's just turn the fan on. There we go, fan's now on. Interestingly, look how many amps it draws. That's quite a hefty few amps being drawn by that fan. Okay, 50 amps being drawn by that. Okay, and you can see the voltage now increased, and again you can see the voltage here has increased, and you'll be able to see over there the voltage over there has increased as well. We got 13.2, we got 13.5 directly on the battery, 13.2 at the back of the van there. Now I'm just wondering how accurate this little gizmo here is, because it's showing that it's got 13.6 volts, whereas here it's only showing 13.2 volts, and here we got 13.3 volts, and over there we've also got 13.3 volts. So that's like 0.3 of a volt difference. So I'm not quite sure why that would be reading 0.3 more, but anyway, you can see that the fan is running at 49 amps that thing's pulling. So let's just turn that fan off again. There we are, fan off, and you can see that amps have dropped down to 0 then. Interesting, eh? We still got a misread here. It's not entirely accurate, which is a bit annoying, but amps now, we've only got 5 amps being pulled out. Let's put that DC-DC charger on, this one just here. There we are, and just see what that does. What I wanted to see was whether it's going to pull it out of here or it's going to pull it out of the battery. Well, you can see pretty much again it's doing a very similar thing. Look, we got 50 amps here, we got 46 just here, or 50 now, That might go on up to 55, but it looks like maybe it's just pulling 5 out of the battery and 50 out of the alternator. Let's see what happens when I put this fan on. Okay, put that fan back up again. Full power on the old fan. Okay, so now it's pulling 100 amps out of the alternator. And bear in mind the engine is just on idle. So if I put this on now, that's going to draw another 50 amps out of here. So let's just try that briefly and see what happens. So I'm going to flick that switch on there, give it a few seconds and just see what this does. Now the danger here is the engine is just on idle, so the alternator is not spinning very fast, so it's not going to be cooling itself down. And drawing 140 amps out of the alternator is going to make the alternator get really hot. So I need the vehicle engine running faster, which will in turn spin the alternator faster, making sure that it gets adequately cooled. And don't forget, in this fan I have a 180 amp alternator, so I'm using about 80% of its power, which I think the alternator should quite happily provide. And I don't think I'd really want to draw any more than 150 amps out of the alternator. So that's why I've got this little gizmo, just so I can keep an eye on things and make sure that I don't overload the alternator. Because obviously if I've got my lights on, the windscreen wipers on, the fan on, I'm going to be drawing a lot more power out of the alternator, so I then want to switch off my DC-DC chargers. But of course I can always upgrade the alternator to a more powerful one. Now to get my DC-DC charger running at this low voltage, I adjusted the input voltage lockout. And I go into that in a lot more detail in my other video, which I'll leave linked above now. So lastly, as said, I'll show you how to find out how big your alternator is. So get your phone, put it on record, drop it down inside the front of the engine here, and there's my alternator down there. And then on the back of the alternator there, next to that plug, one with the green wire in it, there's a little bit of writing. I'm just trying to get my phone hopefully in the right area, because I can't actually see it. I'm just pointing it in the right direction. And there you go. You can see that it says 180 amps on the back of the alternator there. So that's how I found out how big my alternator is. Right, that's about it then. I do hope you found this video interesting. If you want to just leave some comments, then obviously it's great to hear from everybody down in the comments. If you want to slag it all off, then do that as well. But, you know, this is what I found out on my van. And obviously, like I said, I'm not an expert. I'm just sharing with you what I found out. So do subscribe, click on the old thumbs up and share it with everyone else on the van community. And I hope that next video will be of interest to you as well.